Hello friends, welcome back to our channel. So in today's session we'll see one more concept in three address code in compiler design, that is a representation of a three address code. So in our previous session we have discussed about what exactly mean the three address code, and it is a one type of intermediate code generator, and where the complete complex instructions will be simplified with a simple instructions, and making that instruction in the form that every expression will be having at most three operands, and on the right hand side of assignment it will be having only one operator. So that we have seen, and we have seen a few examples of three address code, and in today's session we'll see the representation, how these three address code will be represented. Right, let's start the session. Representation of three address code. So we'll take an example and we'll see, and the mainly three ways we can represent this three address code. So one is a quadruples and triples and indirect triples. Indirect triples. So these are the three ways we can represent any three address code. So we'll take one example, then we'll see how that example, that expression can be represented using quadruples, triples and indirect triples. This is also very important concept. So let us take an example. A is equal to B plus C into D minus E. So let us take this example. So in our previous session already we have seen how this expression can be written in a three address code. So let us take the among all the operators, the parenthesis will be having the highest precedence. So the first temporary variable stores the expression inside the parenthesis, and there is a one more parenthesis. So t1 is equal to d minus e, and t2 is equal to, so you need to multiply these two, so t0 into t1, and a is equal to t2. So this is a three address code. So far we have discussed, right, in our previous sessions. So now how can we represent this particular three address code using quadruples, triples and indirect triples? So first let us start with the quadruples. So here the name itself indicates quadruples means the four parameters. So here it will be using a four parameters. So four parameters. So the first one is result, operator, argument 1, argument 2. So here what we have discussed in our previous session, every statement will be in the form of result is equal to operator operand 1, operator operand 2. So we can call these as arguments, argument 1 operator, argument 2 result. So if any three address code statement represented by using all these four, that is called as a quadruple. So here we'll use temporary variables, and this quadruples representation will be very easy for code optimization, easier for code optimization, or we can say for machine code generation or target code generation. This is best suitable. Okay, and one disadvantage of using this quadruples means it requires more number of temporary variables, because every statement will be having the temporary variables, and so it requires more temporary variables to store the expressions. So let us see this particular three address code in a quadruples. So I'll erase this one, and let us see four parameters, that is a result, operator, argument 1, argument 2. So let us take this one. See, result temporary variable t naught, and see this is an addition between b and c. Result t1 minus, this is a minus, subtraction arguments d and e. Next t2, so operator is a star, t naught and t1. Next result is a and operator is equal to argument 1 is t2 and there is no second argument. So what we have seen, so you can observe this one, this is an assignment type of this 3 address code. So in our previous session we have seen already types of 3 address codes. So in that this is an assignment. So that statement, the 3 address code statement will be having at most 3 arguments. That means the statement can have only 1 argument or 2 arguments or 3 arguments, at most 3 arguments. So here we can have only 1 argument and this is a hyphen, this is an empty. So if the 3 address code is represented in quadruples, this is the form. Okay, the main advantage is it is very much suitable for generating the target code, and disadvantage is, so we are using a lot of temporary variables. Right? So when, in order to avoid these temporary variables, we are moving towards the second category, that means second type of representation, that is triples. So here it will be having only 3 arguments. One is a operator, argument 1 and argument 2. So I am erasing this one. So this is a quadruples. So it will be having only 3 parameters. 3 parameters. So the first one is operator. Second one is argument 1 and third one is argument 2. So what about the result? So here you can see the complete results are in temporary variables. So in these triples we are avoiding the temporary variables. So avoiding result, which mean temporary variable, So we are not using any temporary variables, but instead of using the temporary variables, we are using the, so instead of temporary variable, we are going to use previous triples value or result. Whatever the result we are having previous triple, so that will be directly using in this particular thing. Okay, so here we'll be using some index. Okay, so here the advantage is no temporary variables, but disadvantage is difficult to generate target code. So when compared to the quadruples, it will somewhat difficult to generate the target code, but there are no temporary variables. So in this case there are no temporary variables. So let us see what are these things. Okay, I'll write here. So the first one is a index and operator, argument 1, argument 2. So let it be index 0, 0th index, operator plus, and this is B and this is C. Index 1 minus, this is D and this is E, second statement. Third statement, third index will be star, and here we are not using any temporary variables, but the result is at index 0, result is at the index 1, right? First triple, second triple. So we are using the same thing. This is a first tuple and the result of second tuple. So the multiplication to be done in between the first tuple result and first triple result and second triple result. And 4, which is an operator, so which is the result of this one, the 3. and here there is nothing. So this is the representation of triples. Representation of triples. Okay, so here we are not using any temporary variables, but instead of using the temporary variables, we are making use of the previous tuple results directly. So it will be very easy because I mean there is no temporary variables, but it is difficult to generate the target code. And there is a one more representation that is called a indirect tuples. Indirect triples. So here the name itself indicates indirect triples, which is similar to the concept of triples, but it maintains a pointer list of statements to the triples. So whatever the triples we are using, so one more pointer will be there. Okay, see, let us take, this is a 10, 11, 13 and 14. So it will maintain a one more pointer. So here it is a index and the statement. So 0th index 10, was first index 11, second index 13 and third index it's a 14. So one more table will be there other than the triples concept. Other than the triples, one more variable will be there. See, so 0th index, the first 10. So first statement is at 0th index. Second statement is at first index. Third statement is at second index. Fourth statement is at third index. So this particular list of pointers, this is a list of pointers, will be additional along with the triples concept. So this is an indirect triple, and this is also somewhat difficult to generate the target code. Here also there is no use of, I mean we are not using any temporary variables, but difficult to generate the target code. Okay, so among these three, the quadruples will be easy for generating the temporary, I mean easy for generating the target code, but it will be using the temporary variables. So hope you understood. These are all the representations of 3 address code. So 3 address code is a type of intermediate code generator, and these 3 are the representations of 3 address code. So hope you understood this one, and I'll stop here. In our next session we'll see how we can write the 3 address code for conditional statements as well as iterative statements. So our program will be having both normal expressions as well as conditional statements as well as the iterative statements. So we will see how to write the 3 address code for the conditional statements and iterative statements in our next session. So hope you understood this representation of tag, quadruples, triples and indirect triples. If you are having any query regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. And if you really enjoyed the session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.